Hi everyone, this is the second half of the CEDRS training presentation. If you haven't already watched the CEDRS data collection video, you should start with that one. This presentation is focused on data compilation, stocking status decisions, and results reporting. We're going to start off with data compilation, which should be quick and easy since it's now been mostly automated. You just need to be able to flag mistakes and build forest cover labels.
Okay, we'll dive right in. So the first summary section is the totals averages section, which is just below your tree tally section. Now this section summarizes your tree counts by species, by the relevant layer, and data type. So for this field, it just sums the entered value in each of the T1 rows for this column. So it is 2 plus 3 plus 3 plus 2 plus 2. And then that's repeated for each of these columns and for each of these 5 rows. So in the F1 row right here, this 9 value is the sum of 2 plus 2 plus 3 plus 0 plus 2. And that's just repeated. Then on the left, it is summing these values across species. So 16 is 12 plus 4 plus 0 plus 0 plus 0, 16. And then that's just repeated across these 5 columns. So these are the sums without any m value applied. In contrast, the values over here in the well-spaced and free-growing rows right here are capped. So we have 18 well-spaced for the layer 2, 3, 4 in total, 15 in this capped column. Now in the T1 row, this column is summing the plot swing tallies across plots. So it's 2 plus 1 plus 1 plus 1 plus 2. And we're going to use this value for our inventory density for layer 1. In contrast, we have 16 in trees for layer 1 based on our prism sweeps. Okay, next I want to cover species composition, which is in the section just below. So it just takes the sum value across all plots for the applicable species, and it divides it by the total number of trees for that layer and data type. And it uses total values, not cap values. So for here, it's 12 divided by 16 equals 0.75 times 100, 75. And 4 divided by 16 times 100, 25. Now on the right, these columns are simply adding up the percents across all species. And if it doesn't add up to 100, you know that there's a mistake somewhere and you'll just want to dig into it. Okay, next we have average heights and ages for the stratum 1 and stratum 2 species by layer and by data type. So both the height and age fields just use simple average formulas. So it averages all cells with values in them. So if you have plots where you didn't collect this information, or if you have hidden rows that are blank, these won't be included in the calculation. The crown closure field works in the same way. It just averages fields with values entered. So if you truly have a plot with 0% crown closure, you would need to enter it as 0%. You can't just leave it blank. In contrast, for the plantable, preparable, and germinant fields, a blank is interpreted as being 0. So to calculate the average, you sum all fields, multiply it by the plot multiplier, and divide it by the number of completed plots. If you haven't entered the number of completed plots or the multiplier in the FS 657, these will not automatically calculate. Last up, we have the ground vegetation summary. So this field here basically pulls all unique codes, and then it looks up those codes and it averages the percent cover entry and the height. All right, next up we have the forest health summary. You'll find this in the results reporting section of the spreadsheet, but there are a ton of additional fields and calculations to produce this information. And you can see them if you scroll to the far right and then hide columns AU to BG. This then pops up. Now, if there's anything that's going to break or glitch in this entire spreadsheet, it's going to be this section. These are all pretty complicated, but if you look at the percent hosts column in particular, the formula is absolutely insane. It is way beyond my Excel abilities. I was only able to get this automated thanks to AI. Given the formulas are so complicated, please do a double check that they're functioning properly. To do that, you'll just use the normal formula It is complicated since you're having to do it by layer. And when there's multiple species affected by the same pest, it adds on a level of complexity. I'll show you on the next slide. Okay, so given the potential finickiness of this formula, we're going to always just check at least one of the damage agents and ensure that it's working. So we're going to check out AD. It only affects the understory trees. We're looking at layers 2, 3, and 4. So to do this formula, we start off by adding the living affected trees with the dead affected trees. So we look across all of our plots for any records of AD on the understory. We have it in plot 4 and 5. And it's just living trees that have been affected, no dead, so it's just 1 plus 1. So our numerator is 2. Then for our denominator, we are going to multiply the total trees for the layers 2, 3, 4 by the percent host species composition. So cedar was affected and hemlock was affected. So we go to the layer 2, 3, 4 total trees and we add up the percent composition. So it's 0.66 plus 0.17. So that gives us 0.83. And we multiply that by the number of total trees in layers 2, 3, 4. And so we have that right here, and it's also right here. So it's 47. So it's 0.83 times 47 equals 39.01. If we had any dead affected trees, we would add it on now. We don't. So it's 2 numerator, denominator, 39. So we go 2 divided by 39. And we multiply by 100. And we get 5.1. So 5%. That matches with what's showing on the spreadsheet. So hooray, it seems like it's working. Okay, now to wrap up our data collection, we have to calculate our densities and basal areas. This happens in the summary table on the far left at the very bottom. There's a column for layer 1, the overstory, and a column for the combined understory, layers 2, 3, 4. All the values in this table are easy to calculate. For the densities, you're just multiplying the totals by the plot multiplier and dividing by the number of completed plots. For the basal area, it's similar. You're multiplying the total number in by the BAF and dividing by the number of completed plots. Now, for results reporting, you do need to report well space preferred and free growing preferred. If your standards match the implementation guide, then these numbers will always just match with your well space per hectare and free growing per hectare, given all species are listed as ecologically suitable and treated like they're preferred. If your standards actually do split between preferred and acceptable species, then these formulas work. Check them out. It will calculate the percent preferred based on P or RP being entered into this row. Okay, with all that data summarized, we now have to make a stocking status decision. So it starts off with the stratum's crop basal area. So that's actually right here. This is 12. Now, the crop basal area for the stratum is going to set the stratum's minimum stocking standard. So 12, we're within this grouping right here, 9 to 15.99. So that makes our stocking standard 800, 400, and that automatically populates right here. Now, if our minimum is 400, then our well space density has to be above 400, and it is, it's 580. So we are at minimum SR. Then we look at our free growing numbers. We are at 440. We're close to the minimum, but we're above it. And so that means we are free growing. For cedrus, very luckily, no stats are required, so the LCL does not matter. So just the fact that our average free growing density is above the minimum is enough to mean that at the stratum level, we are free growing. However, you do also need to consider, are there any areas within the SU that do not meet the stocking standard on a plot level basis? So for that, you're considering the plot's stocking standards, not just the stratums. So we go through all of our plots, and you're also doing this as you walk through. It's not supposed to be done afterwards. And we're comparing. So here, our minimum's 400, same as the stratum. And we have 400 well space, 400 free growing, given our multiplier is 200. Next plot, MSS is 500. We had 3, so we had 600, pass. Next, 350. We had 3.5, so 700 and 400, so pass. Next, 400. We had 400 for well space and free growing. And lastly, 400, and we had 800 and 400. So all of our plots individually also pass. So overall, that means our SU is free growing. We are good to go. All right, I'm now going to show you how to put together forest cover labels. Unfortunately, this is not automated in the spreadsheet, and I'll start off with your layer 1 inventory. So for it, you have to start off with species composition. So we go to the species composition section right here and to the T1 row. And so we have 75% hemlock, 25% cedar. We have to make sure that we just order the species from highest to lowest, and you can see that's done right here. The next part of the label is always age, starting off with your stratum number 1 species and then followed by the stratum number 2. So we go to our T1 row. Our leading stratum species is hemlock and our age is 133. Then our second stratum inventory species is cedar, age 130. And you can see that here, 133/130. Then we do the same thing with heights. So we pull 35/3, 28/7, and that's the next portion of it. After that, we're doing crown closure. So crown closure for layer 1, we go to the T1 row, it's 48%, enter that here. And then lastly, we did do inventory because our status is IMM. So we go to the layer 1 column of the summary table, total trees per hectare 280, and we write that in, and then in brackets, the year is 25. And you'll note that we don't have site index or site index source because it's going to be for the polygon component, not by layer. If your client, your licensee wants you to do it for each of these layers, you can, you just aren't going to report it. Okay, next we have the forest cover label for our layer 1 silviculture, and it's simple. We now just go to the F1 row and we pull the species composition. It happens to be the same for this example, and once again, we just order it from highest to lowest. So hemlock 75, cedar 25. Then we do the age of our leading silviculture stratum species. So it's from the F1 row right here. Hemlock, our age is 133. And that's right here, and then we do the height. So it's just this column, 34/7, entered right there. There's no free growing density, no well space density to put at the end, so we just wrap it up with the year 25. All right, now we do the inventory label for our combined understory layer. And so concept is basically the same. We're just pulling now from the T2, 3, 4 row. So pulling from this row, and we have more species here, so we need to make sure that we do order it from highest to lowest. So it's going to be hemlock 66, cedar 17, balsam 11, alder 4, fir 2. And you'll see that it has been ordered that way right here. We then pull the age of our leading inventory species for the combined understory. So it's hemlock 13. Right here, and then we do the same for the secondary stratum species. So again, 13 right there. We repeat this now for heights. So we pull first from the stratum 1, 4.4, and then 4.3. You can see that right there. Next, we do crown closure. So again, just pulling from the T2, 3, 4 row, it's 27%, 27. And then we do our layer 2, 3, 4 total trees per hectare, our total density, 1880. Right there, and wrapping it up with the year 25. All right, now to wrap up, we just have to do the silviculture label for our combined understory layer. And we start off always with status. So our status is right here. This stratum is FG. So we do FG, then we put a dash, and then we do the species composition of our free growing trees. And all the data within this label will be reflective of the free growing trees, given our status is FG. If it was SR, we would instead put the well-spaced information. So for species composition, we go to the F234 row, and we have our species comp right here, and we just have to order it from highest to lowest. So it's going to be cedar first, cedar 45, and then hemlock and balsam happen to be equal, so you put either of them next. So I did cedar 45, hemlock 27, balsam 27. And then we have to do the age of the leading stratum species. And this is for our silviculture sample tree, so 13. And then we follow that up with the height, 4.2. And then we do our free growing density. So We're pulling the free growing per hectare right here, not the free growing preferred. So it's 440. And then we wrap up with the year, 25. Now to wrap up, everything else in this table also needs to be reported to results, and I'll just go over it quickly. So first we have forest health. This needs to be reported as part of the inventory component. Any damage associated with layer O will be reported under the layer 1 inventory. Any damage associated with layer U will be reported under the combined layer 2, 3, 4 inventory. Next, we have total well space. This isn't part of the silviculture label, but it is a required reporting element. It'll get reported under the combined understory silviculture layer. Then there's total basal area, and this will be reported under the layer 1 inventory. And then crop basal area will be reported under the layer 1 silviculture. Lastly, these 5 data elements will all be reported under the polygon component for the stratum. Okay, the very last thing is this declaration field. So we now legally have to do declarations for free growing in results. And with that declaration, there's a comments field. In the comments field, highly recommend indicating that the stand is under CEDRs, and I'd clearly state the crop basal area, the corresponding MSS, and then the understory free growing or well space density. This just ensures that it doesn't get unnecessarily flagged in compliance audits. Okay, I'm now going to show you an example of a forest cover submission to result for a standards unit which is under CEDRs. So this what you see when you first open up the forest cover tab for your opening in results. And I can see that I have one SU, one stratum, and there's 4 reported layers. Of the understory layers, layer 3 must have been most abundant by total density, since the information for all 3 of the understory layers has been reported into layer 3 and layer 3S. Reporting into layer 2 or 3 will be most common at free growing, whereas reporting into layer 4 will be most common at regen delay unless significant advanced regen was retained during harvesting. Then if you click any of these details tabs, the polygon component will pop up. That's this section. Everything that's been filled out in this example is mandatory. The most common missing elements, which are legally required if the stratum is multi-layer, are tree cover pattern, reserve type, and reserve objective. And I went over these fields in the last video. I also went over site index and stocking status in the last video. Both of these fields, along with stocking type, are based on the layer with the highest expected volume at the next rotation. So you're going to see in a minute that this stratum has 12 meters squared total basal area and almost 4,000 stems per hectare of understory trees. In 100 years' time, let's say that's going to be our next rotation, there's going to be more volume from the understory trees versus on the current residuals. So stocking status for this example gets entered as IM, and our stocking type is ART because our understory trees were planted, and our site index species is hemlock, which is the layer 3 leading inventory species. All right, now if you scroll down that forest cover window below the polygon component, you'll then see your layer 1 inventory and silviculture information. So for your layer 1, you can see all the normal information. You have your species composition, which was based on your prism count. You have your heights and ages for your leading and secondary species. You have crown closure. You have density because our status is IM. And then we also have total basal area. We also have forest health reported. And again, this is just damage on specifically the layer 1 trees. We then have our silviculture label for our layer 1 trees. And we can see that we have crop basal area reported, and we don't have well spaced or free growing because that's not a component of our CEDRs tables. Then for our combined understory layer, it's been reported to layer 3. Other than that, there really are no differences from a regular even age forest cover submission. We have all the normal attributes, including total well space, free growing, and we do not have any basal area associated with this because basal area is only done on your layer 1 trees. All right, that's a wrap. Thank you so much for watching. If you have any questions or feedback, you can contact me at the email on the slide. Happy surveying!